Hello everyone, here is a question from thermodynamics. Consider the following cases of standard enthalpy of reaction and figure out the magnitude of standard enthalpy of formation of C2H6 gas. We need to figure out the answer but write only the magnitude. So this means that if we have a negative sign, then we should ignore it. And we have to find out the answer in kilojoules per mole. We have to find out the answer the nearest integer. Now, the standard heat of formation or standard enthalpy of formation of a compound is defined as the change in enthalpy that takes place when 1 mole of a compound is formed from its elements present in their standard states under standard conditions. So, this means we have to consider 1 mole of C2H6 gas. How we can get 1 mole of C2H6 gas? If we have 2 carbon exists as graphite in the standard state, and then hydrogen exists as H2 gas in the standard state, then we can get 1 mole of C2H6 gas. Now think about how we can get 1 mole of C2H6 from these 3 equations. Like basically how we can arrive at this equation using these 3 equations. What changes do we need to do? We have to multiply the second equation by 2 because we require 2 carbons, isn't it? So this entire equation we need to multiply by 2, and then the third equation we have to multiply by 3 so that we can get 3H2. And the first equation, the C2H6 is on the reactant side. So this means we need to reverse the equation. We need to bring it to the product side. So if we bring it to the product side, what will happen to delta H1? Delta H1 naught will become minus delta H1 naught. Because if we are converting reactants into products and products into reactants, then we need to change the sign. Let me put it this way. So we have multiplied with all the factors. So if we have these 3 equations, so if we sum it up, then what will happen? We have 3 waters on the reactant side, we have 3 waters on the product side. That would cancel out. We have 2 moles of O2 on the reactant side and 3/2 moles of O2 on the reactant side. So if we sum it up, then that will be 7/2. So we can cancel that. And we have 2 moles of CO2 on the reactant side, 2 moles of CO2 on the product side. So if we sum it up, then we will get this equation: 2 times carbon plus 3 times H2 gas, and that would give us 1 mole of C2H6 gas. For that we are finding the standard heat of formation. So therefore the standard heat of formation for C2H6 gas is equal to minus delta H10 plus 2 times delta H20 plus 3 times delta H30. Therefore this is equal to 1550 because we have to change the sign, plus 2 times minus 393.5 plus 3 times minus 286. So therefore delta H formation standard is equal to 1550 minus 787 minus 858, and that is equal to 1550 minus 1645, and the answer we will get it as minus 95 kilojoules per mole. However, we have to enter only the magnitude. So that means 95 kilojoules per mole is the correct answer, not minus 95 kilojoules per mole. We have to enter only the magnitude. Therefore 95 is the correct answer.